Have you ever paused to ask, and I said this, but is it actually true? Or thought, the model sounds very convincing, but why did it make that decision? In an era of AI-driven transformation, producing information has become remarkably easy. Text, images, code, everything appears in seconds. What truly makes the difference is the ability to verify the accuracy of the output, to see its limits, and to steer it when necessary. This is because when AI systems generate information, they optimize for a specific goal. They amplify whatever you measure. If that goal is flawed, the outcome heads in the wrong direction. Let me use an analogy. Today, AI is like an autopilot in our pockets. It maps the route, offers recommendations, and sometimes makes half the decision for you. But for an autopilot to operate safely, two things are essential: accurate sensors and correct control rules. Mathematics is what calibrates AI's sensors and defines its control rules. Without mathematics, a system may follow a route that looks correct but is in fact wrong. And the faster it goes, the larger the error becomes. That is why mathematics is critical not only for using AI, but for understanding and directing it. This also aligns with how AI works. Most models optimize an objective function. Performance is evaluated through metrics. Uncertainty, bias, and generalization are all defined in mathematical terms. Even the question, "Is this model good?" is fundamentally a mathematical one. Good according to which metric? On which data? What type of error is acceptable? This is not merely an abstract claim. Google DeepMind's CEO, Demis Hassabis, has noted that if he were a student today, he would focus on fundamentals such as mathematics and physics, stressing that these foundations are essential for truly understanding AI. Yann LeCun similarly argues that young people should rely on long-lasting fundamentals, especially mathematics, rather than tools, because while technology changes, these fundamentals remain. So, what are the concrete benefits of mastering mathematics? Verification power. You ask, under which assumptions was this output produced? Instead of relying on intuition, you can assess error margins, generalization risk, and uncertainty quantitatively. Control power. You understand what the model is optimizing: loss functions, constraints, costs. No correct model can compensate for a wrong objective. Steering power. You stop seeing AI as a black box that merely produces outputs and start treating it as a tunable system. You ask better questions about which data matter, which signals are noise, and which variables distort the result. In the age of AI, many will generate information, but the more valuable ones will be those who can verify it, catch errors, and steer the system toward the right goal. And the shared language of that control is, more often than not, mathematics. Do you think we are using AI more like an autopilot? Or are we truly taking hold of the control panel?